Now that they're the third and final segment for Chapter 7, Week 2, we want to know how to write the formulas and look at the three different properties we find with ionic compounds. Writing formulas, you have to be able to figure out what type of cation and what type of anion there's going to be, because we're looking for the simplest whole number ratio of those two elements. So first of all, write the symbol of the metal and its charge. So aluminum's in group 3. Looking at my camera, 3. So that means it's going to lose 3 electrons. It ain't going to gain 5. So if it loses 3 electrons, it becomes Al3+. We look at oxygen. Oxygen's in group 6. So it's got 6 valence electrons. Gain 2 or lose 6, it's going to gain 2. So when we get the metal and its charge and the nonmetal with its charge, we simply write the symbol with the charge. Okay, after we get that, we find the magnitude, which is just the number of the charge on each one without the sign. And a lot of people that want to make mistakes, they add the signs with them right now. Now, each magnitude or the number becomes the amount or the subscript for the other one. So if you notice, 3 comes down here with the oxygen. The 2, and that 2 minus should be up there. I don't know what happened in the formatting. The 2 will come down on the aluminum. Now that tells me I have 2 aluminum and 3 oxygen. And in doing so, it becomes the simplest whole number ratio of combining those. Now, what do we know about all ionic compounds is the net charge will be 0. And that's really why you're doing that little crisscross method. So if you can, in part 3 here, it says, if possible, reduce the subscripts. That's if I had a 2 and a 4, I would reduce it to a 1 and a 2, or if I had a +2 -2, I would just leave it. I'd reduce it to 1 each. But basically, if you look at, if you have 2 aluminums that have 3 pluses, you get 6 plus total. If I have 3 oxygens with a 2 minus, multiply those together, you get 6 minus. They end up canceling each other out, is what all ionic compounds do, because it ends up forming a crystal. So that's just the crisscross method. Easiest way of writing formulas. Now, the last part that we want to do is just go over the 3 main properties of all ionic compounds. Number 1, they're crystalline, they're solids. Why are they solid? Because they're strongly bonded together. Their structure ends up being very rigid. They form a very tight bond. Okay, that opposites attract is a very strong bond that holds them tightly together, which means if they're held tight together, in order to melt them, to make those molecules slide past each other, those elements, you're going to have very high temperatures. And that's, again, because it's very strong, very crystalline structure. The third thing is that they will conduct electricity, but here's the key: only when melted or dissolved. Now, the problem with melting them is it takes such high temperatures, so that doesn't happen as very often. But most ionic compounds dissolve in water, which means they can conduct an electric current. So if we look at salt, for example, so in order to actually melt it, it takes 800 degrees Celsius. But it will easily dissolve in water, which then allows it to conduct electricity. So all ionic compounds, it's a metal bonded with a nonmetal, will have these 3 properties. That's basically it for the end of Chapter 7. Remember, we forgot metallic compounds.